Hello everyone, and in this video we are going to talk about the slope of the line. So we first start by observing what we see on the screen, two coordinate planes, one on the left with two lines that if I would have to describe them, I would say, fallen from left to right, but seem to have the same tilt, which means that they are not going to have a chance to intersect and thus they must be parallel. On the right, rising from left to right, but as the pair on the left seem to have the same tilt as well, which means that they are parallel. Now, what would be even more interesting now is to look at the equations of this line and to figure out how these observations I just made about these graphs are related to their equations. And the first thing that comes to my attention is that the left sides of these equations are identical, as well as left side of these two equations are identical. So then I would like to conclude that the fact that their left sides are identical must be related to the fact that they have the same tilt. And thus, we are about to learn how the tilt is related to the parameters of the equation, linear equation, ax plus by equals c. But to understand it better and to see, to easily, see the relationship, first thing that we are going to do is to transform this equation. Question is how? Answer, we will solve it for y. Okay, so let me do it here on a clean slide. So I'm going to rewrite ax plus by equals c. We said we will solve it for y. To solve it for y, I need to move ax to the right side. So it's going to become by equals negative ax plus c. And then I'm going to divide both sides by b to isolate my y. And this is the equation I'm going to get. I'm going to separate the terms on the right side. So this is going to be negative a over b x plus c over b. So this is a new form of a linear equation called slope-intercept form. The truth is that you will never see it in this form, and this, I should say, a transcription in the math books. Why? Because in the math books, this negative a over b is going to be replaced with lowercase m. So this is going to be mx. And this c over b is going to be replaced with a lowercase b. And this is the form that you are going to find in most of math books. It's called slope intercept form. And why is this name, or where is this name coming from? M is the slope and B is the y-intercept. Okay, so to understand better the significance of these parameters, I will go back to one of my previous examples. So I'm going to take this equation, 2x minus 3y is equal negative 3. I will solve it for y. So what is this going to be? Negative 3y equals negative 2x minus 3. Right? Now divide both sides by -3. So what do I get? Y equals -2 over -3 is going to be 2 over 3x, 2/3 x, and -3 over -3 is +1. Okay, so this is now the slope-intercept form of my equation, and the slope is equal to 2/3, and the y-intercept is equal 1. And now I will graph this equation as if I've never seen the graph before. So, but this time I will use this new form of my equation, y equals 2/3 x plus 1. So I will start the same way I did in my previous video. So to graph the line, what do we need? We need ordered pair solutions, right? What does mean ordered pair solutions? Points whose coordinates satisfy the equation. I'm going to record them in T-table. And if you remember, to find an ordered pair solution, what you can do is to choose a value for either variable, plug it into equation, and solve for the other variable. Well, a choice of x equals 0 seems very appealing to me. So this is what I'm going to try now. So what is this going to be? 2/3 times 0 plus 1. Well, multiplying by 0 makes everything disappears, right? So the whole term disappears, and I end up with y equals 1. Okay, so this is my first ordered pair solution. I'm going to plot it on my coordinate plane, and I'm going to label it. It's going to be 0, 1. And now I'm going to use a trick. Instead of repeating similar steps for additional points, I'm going to use the slope, 2 over 3. How? Starting at this point, what I'm going to do is to move 2 units up and then 3 units to the right. So I'm going to end up at the point with coordinates 3, 3, right? And I claim now that this point actually is also on the line, which means that the coordinates of these points satisfy the equation. Well, let me check. 3, which is y, I'm going to plug it into my equation. Let me maybe write it first so you would see it even better. So what was it? Y equals 2/3 x plus 1, right? So 3 means x is 3 and y is 3. 3 equals, right? 2/3 times 3 plus 1. Okay, so what do I see? 3 and 3 cancels, right? So what do I have left? 2 plus 1, which is 3. So what do I have? 3 equals 3. That is a true statement, right? So 3 is another ordered pair solution that satisfies my equation. So what if I repeat the same steps now from this newly discovered point with coordinates 3, 3? Well, let's try. 2 steps up, 3 to the right. What are the coordinates of this point? 6, 5, right? I believe 6, 5. Okay, let's see if this point also has coordinates that satisfy the equation. So now y is equal 5. So I replace y with 5. I apologize. I got too far. 5 equals 2/3 times 6 plus 1. Well, I can divide out 3 from 6, and it's going to be equal 2, and from 3 it's equal 1. So what do I have? 2 times 2 is 4, plus 1 equals 5. Well, another true statement. So, which means another order pair solution. And to introduce you into even more tricks, what I'm going to do now is to recall a few things that I learned previously in algebra. So my slope is equal to 2 over 3. 2 over 3, what is the ratio of two positive numbers? And I know that the ratio of two positive numbers could be presented actually as the ratio of two negative numbers, negative 2 over negative 3, because negative over negative equals positive. And what I'm going to do now is to use the steps according to this ratio, negative 2 over negative 3. So for that, I'm going to go back into my point that I first started at, with coordinates 0, 1. And now I'm going to move 2 units down and 3 units, to the left. And I'm going to end up with at this point, and the coordinates of this point is what? Negative 3, negative 1. Okay, let me see if this point will satisfy my equation. So y now is equal negative 1. So 2/3 times, what is it? Negative 3, right? Plus 1. What do I see? 3 and 3 could be canceled, but I'm going to be left with negative 1, right? Or I could say 2 times negative 3 is what? Negative 6, and divided by 3 is negative 2. So this is going to be negative 2 plus 1, which is negative 1. And that's another true statement. So this order pair satisfies my equation as well. Okay. So what can I now do? Well, first of all, I can connect these points, and that's how I'm going to get the graph of my equation, right? So I could claim that I used the slope to graph the line. And what I can also safely conclude that the tilt of my line is defined by its slope, 2 over 3. What I'm going to do next is to do an inverse thing. I'm going to go from the coordinates of order pair solutions to the slope. For that, again, I'm going to look at this graph of the line, so I can identify a few points on this graph that I know what the coordinates are. So this one was 0, 1, and this one is 3, 3, right? So what did I do? I went, so how did I move from, this point to this? I went 2 points up, right? And 3 points to the right, right? So I can call this a rise, and my rise was equal to, and I can call this movement as a run, and my run was equal 3, right? So the question is, how can I relate the coordinates of that point, of the points to the rise and to the run? And what is clear to me that the rise, F2, is actually equal to the difference of the y coordinates of my points, because 2 is equal 3 minus 1, right? So that's how I can relate rise to the coordinates. And the run, which is 3, is actually equal to the difference of the x coordinates of my points, right? 3 minus 0 equals 3. Okay, so remember the slope was 2 over 3, right? And we labeled 2 as a rise, and we labeled 3 as a run. And we said the rise was equal to the difference of the y coordinates, 3 minus 1, right? and the run was equal to the difference of the x coordinates, which was 3 minus 0. Then the question is, what if I choose another pair of points? Would I be able to obtain the same ratio of the difference of the x coordinates and y coordinates? Well, let's try. This seems to be another point. We've actually used it before, 6, 5, right? 6, 5. Now, what is, hold on, this is going to be the rise now, right? And this is going to be the run. So the rise, let me, not yet. I'm not going to be able to claim this, that is my original m, until I actually calculate it. So let's just find what is going to be the rise and what is going to be the run for these 2 points, right? So the difference between y coordinates is going to be what? 5, this is 5, this is 1, so 5 minus 1. The difference between x coordinates is going to be what? 6 minus 0 equals 6. So this is going to be 4 over 6, but 4 over 6 could be easily reduced to 2 over 3. So what do I get? I get the same ratio. And from here, perhaps I could conclude that thus, if I would choose any 2 points on this line and I label them as x sub 1, y sub 1, and let's say x sub 2, y sub 2, and let me use a different color so it would be better seen. So the ratio of the rise, let me see, the rise over the run of these points is going to be equal to the slope of this line. So m as a rise over run equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, and this actually is the formula that you will find in all mathematical books that is going to be a formula to find the slope if you are given the coordinates of 2 points that lay on the line. So let me label this again. This is going to be what? Y sub 2 minus y sub 1. And this is the rise. And this one is the run, which is x sub 2 minus x sub 1. What else you can see in mathematical books is instead of writing y sub 2 minus y sub 1, in math, the difference of variables is very often labeled as delta. Delta stands for difference, as delta y over delta x. So if you see delta y over delta x, that means it's the ratio of the difference of y coordinates and the difference of the x coordinates. Okay, so what have we learned so far? Well, first, we realize that the slope defines the tilt of the line, right? Then the slope can be used to graph the line, and the slope can be derived from the equation of the line, right? If we solve the equation for y and convert it into slope-intercept form, or it could be calculated if you are given 2 points that define the line. And before I will end this video, I want to look at something else. So these are 2 graphs that we saw on the first slide. So what do we see? On the left side, there's a line with the equation 2x plus 3y equals 3. And on the right, it is the equation, the line is the equation to x minus 3y is equal to -3. And they seem to me on this slide as if one was a mirror reflection of the other, right? So let's see now what are going to be the slope of these lines, and then we are going to relate this, interesting fact that, why is one line is falling down and the other one is rising up as we move from left to right. So I'm going to take, let me change the ink. I'm going to take the first equation and solve it for y. It's going to be what, -2x plus 3. Then I divide both sides by 3, and what do I get? Y equals -2/3 x plus 1, right? So what do I see? The slope of this line is equal -2/3. And for this one, 2x minus 3y equals -3. -3y is going to be equal -2x minus 3. And then I'm going to divide both sides by -3 to isolate my y. So this is going to be 2/3 x plus 1. So I see the slope of this line is equal to 2/3. Then what do I see? This, the graph of the line with the negative slope is falling from left to right. And the graph of the line with the positive slope, 2/3, is rising from left to right. So negative slope will make my graph fall from left to right, and positive slope will make my graph rise from left to right. And again, if I see the line and I see that the line is falling from left to right, I should know right away that the slope of this line is going to be negative. And if I see the line and the line is rising from left to right, that I should conclude that the slope is positive. And the question that I'm going to leave you with in this video is, what do you think is going to happen if the slope of the line is equal to 0? And one last thing that I would like to mention before I'm going to finish this video is, we talked about the slope-intercept form of the equation, right? And we talked a lot about slope and how is that slope reflected or related to the tilt of the line. But we never said anything about the y-intercept. Well, the y-intercept is going to be the topic of our next video.